Hey everyone, welcome to our DevOps office hours. It's November 16th, 2022. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. Cloud Posse is a DevOps accelerator, and we help companies conquer AWS using our proven blueprints. If you're starting from scratch or just not happy with the state of your infrastructure today, head over to cloudposse.com/quiz to book a session with me directly, and I'll show you what that future could look like. For those of you new to the call, the format is very informal. My goal is to get your questions answered. If you're curious about Cloud Posse or any of our open source tools or modules, this is a great place to ask. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by heading over to cloudposse.com/office hours. We host these calls every week. Our call today is recorded, and we're automatically going to post a recording of this session to our YouTube channel. So if you enjoy the content and want to support what we're up to over here, please hit those like and subscribe buttons. Just head over to youtube.com/cloudposse. Again, that's youtube.com/cloudposse. So with that said, I'm going to jump over into the announcements. Lots of cool little things this week that came across my desk. So the first one is something that I have a little bit more FOMO on. Anybody who has been using Jira for years is always looking for the next alternative and never being able to settle on something. So GitHub has actively been investing, or Microsoft rather, has been actively investing in GitHub projects. I think the longer term goal of that is, of course, to usurp Azure DevOps and take the best of everything and combine it into one product. Back in July, they announced an overhaul of the GitHub projects. And now with this release, they have added some more productivity hacks to improve the usability. So you can have inline checklists on your tasks and check them off, which is pretty nice. And roadmaps, which are essential for anyone doing project management. So the fact that they've added that to this tool makes it a much more serious contender. Just showing one of the things that we've been playing around with at Cloud Posse. Well, playing around. This is more like anybody who hasn't even looked at it. Just something to understand kind of what's cool about it. So one thing I love about it is that with GitHub projects is it supports both like a table-like view as well as a board-like view. So depending on how you want to do your work. And then because one of the things we've realized is depending on who you're talking to, are you talking to a customer? Are you working with a team? Are you doing a stand-up? Are you doing something else? It can be helpful to have different views of the same tasks. So I love this ability of this to very easily filter pretty much on any criteria. Basically, anything you can do with GitHub search, you can create a new view on your tasks and work with. So has anybody been using successfully GitHub projects or unsuccessfully? In the new incarnation, not GitHub Projects Classic. All right, that wraps up that. Next announcement was from Spacelift. This is pretty cool. So Spacelift has introduced this concept of spaces, and it's kind of like a namespace almost for your resources. It is a construct that allows you to organize all of your Spacelift stacks logically in a hierarchical way, similar to organizational units in AWS. And then associate those with teams and policies. And by doing this, you don't overload teams with 1,000 stacks in the UI, of which 1% of them are relevant to that team. And with this, you can do that, and then you can also do policy controls on top of that. Here's kind of, this is a little bit small to see, but here you can kind of see how you can organize now all of your Spacelift stacks in that UI. I think a nice way to do this as well is if you organize your Spacelift administrative stacks. So you have one administrative stack per team at a minimum. And then that also helps you, give those stacks different IAM roles that they can use to execute their workloads. Any questions on this? The next announcement is just a minor one. If you're using GitHub Actions in an organization and you have people forking those repos by convention or having private forks, you can now prevent those GitHub Actions from running automatically. And that can be pretty annoying, actually, when you get a lot of failed builds because they don't have secrets or other things like that. The next announcement is pretty cool. This is in a beta still, so I don't believe it's generally available, but you can apply to use it. GitHub Actions has developed an importer tool, so you can now migrate your workflows that you've written for like Azure DevOps, CircleCI, GitLab, Jenkins, Travis, and translate those to the GitHub Action schema. Now, that makes a lot of sense because it's all YAML these days, right? So it's not a leap of faith to see how you could transform one YAML definition of workflows into another one for GitHub Actions.
Yeah, so I'll just comment on one thing that I tried this with the CircleCI one because I have some stuff running on CircleCI. And what wasn't obvious to me right away when I started was that it doesn't just automatically convert all of the CircleCI orbs, obviously. So if you're referencing other things, like then that doesn't just somehow magically become like a GitHub action. So it's only somewhat useful if you're doing that, you know.
I feel like I've seen a GitHub action to run orbs. I don't know.
That could be, yeah.
I mean, this is old now here, but somewhere else I saw it, and I'm not saying this is a good strategy, but like as a stopgap measure to quickly migrate, that'd be kind of a cool strategy if there's just something.
Yeah. So my only point there was that all of these other CI tools realized that building reusable pieces of what GitHub Actions are, like their equivalent of GitHub Action. They built all those things out, and then this thing doesn't actually automatically import all of those things. So you still need to figure out what you're going to do with all those reusable pieces. So this isn't as useful if you've got a large, a large implementation that's using those.
Large. Go on.
That would be sort of my first question, really. I mean, you mentioned sort of import it from YAML. So like Jenkins jobs defined as YAML was one thing. The massive amounts of, well, in many cases, I've seen sort of like legacy sort of Jenkins shared library, sort of shared libs, like the sort of very domain specific stuff. Is there any kind of support for that, or is it really just YAML format kind of?
No. So like all the Jenkins plugins that do various things, like you would have to find or write a GitHub action that, unless there's a GitHub action that runs Jenkins plugins. Like, I know that so maybe. But like in that case, you would have to do that. I would find that hard to believe.
I would find it hard to believe, but I'm never surprised by what people
because that one actually has like a specific interface, and they use like I think they use RPC to actually like start a server in the Java server, and then they pass like specific calls to it and all of that kind of stuff. So it's a little that one would be a little bit harder. The orbs, I get like how they could do that, but Jenkins plugins would be hard.
Cool. The other one is if you are an Atlantis user and you've been following the project, a number of months ago, they released APIs in Atlantis, so you can remotely trigger plans and applies through that API. Now, the impetus for doing that is so you could do cool things like this. So now you can roll out a GitHub Action workflow. This is not it. They document one down here below to detect drift of your Atlantis stacks, which has been one of the problems when you use Atlantis is like, sure, you have confidence you can deploy at that commit at that point in time, but you don't have confidence that you can deploy today, and you don't have confidence that things haven't changed either manually or for other reasons because of lack of version pinning or something like that. So this is a way you can now implement drift detection with Atlantis. The next one is a small one. I forget if I brought this one up before. Oh, I linked the wrong thing here. But sure, we could just do that and find the same thing. There's a, this is not it either. Anyways, it was via the, well, the easier way is just to go to weekly.tv. My dogs. Yeah, so Anton Babenko's newsletter, he had an interesting provider here. If you need to, for some reason, access environment variables natively from within Terraform without using like the TFVAR convention and doing that. For example, you want to access existing variables in the environment, like the home directory or something like that. This provider can let you do that. And it looks
So,
like before.
So that almost sort of the equivalent of like the Kubernetes downward API for Terraform. So it's, I mean, essentially, like if you're running and I don't want to sidetrack too much, sorry. Essentially, if you're running a container, you're able to then basically expose from the node it's running on and actually grab sort of environment variables and
Yeah. Then you can do something equivalent to that, right? Yeah,
it's quite cool.
yeah. So, I mean, I would caution against using too many environment variables, but it's great for just like getting your context where something's deployed without needing to have Terraform variables. And specifically, like what you mentioned is pretty cool. For example, if you're running this in a Kubernetes context and you have a lot of environment variables at your disposal, you can now read those natively.
Yeah, so I would also just say with you know, great power becomes great responsibility too in this one. Like, be very careful because environment variables obviously often contain secrets. So like Terraform's done a lot to be careful about the secrets that it already works with, like AWS secrets when it imports it into the AWS provider, et cetera, et cetera. But if you read environment variables using this, they'll be included in plain text in plans and included in state and a bunch of other things without being marked as sensitive. So be careful.
That's a really good point.
Stop worrying. I really want us all to stop worrying and let people set themselves on fire. We don't have time to stop that. Let's get on with productivity.
Yeah. Well, it depends. If you're the designated fireman, then you want to try to make people not set themselves on fire.
Throw that hat in the garbage. That's an awful hat.
Yeah, but even there, I kind of had to agree. Like what would the word be? The best way I've seen it so far when it comes to like correcting engineering behavior, when it comes to the managing of like secret things, especially in Terraform state, is catch it in a pipeline. Catch it on pipeline beforehand and fail the pipeline.
Love it. It's perfect.
Yeah, ideally that is a good enough stopgap. The other point I would caution against with environment variables is, well, it's a little bit less deterministic what's going to happen if you don't have a systematic way those environment variables get set. So the outcome of me running everything locally might work perfectly because I've set that one esoteric environment variable. And then when we go to staging or dev or something, it fails. Obviously, hopefully it fails early, but maybe it works in dev, maybe it works in staging. It doesn't work in prod because that same environment variable was not set there either. So environment variables like this, whoever said it, it's a slippery slope. So. Okay, anything more to add to that before we move on to the next point? All right. The next one, I didn't actually get a chance to read this one yet, but conceptually seemed really interesting. How we use Terraform at Slack. So every time there's a company that comes out, obviously using Terraform at a relatively significant scale, I find those articles interesting if there's some meat to them. I'll be honest, I did not get a chance to zip through this one yet. All right. And one that's near and dear to my heart. I'm really excited to announce that we have published an updated Atmos documentation site. We upgraded it to DocuSource v2. We overhauled all the content. It is pretty substantial in a lot of areas. There's still some stub pages that could use some more love. The areas that like we've just worked on today would be like component inheritance. This is probably the largest differentiator of Atmos and the hardest thing to solve in general, and what every other tool similar to this fails to do in the at least Terraform space, is how to do advanced concepts of like inheritance. So Atmos solves inheritance at the configuration layer. So we're not magically introducing inheritance into the Terraform core. We are solving it in how you manage complex configurations where you want to be dry and at the same point powerful and tie in all that data. So Andre on the team wrote this up, and it's a great write-up if you are using Atmos and want to leverage some of the more complex capabilities of the tool like inheritance. Check that out. We also go over just, conceptually, what are components, what are stacks, what are workflows, and what are subcommands. Those are like the cornerstones of Atmos. Workflows are how you can systematize a process that you do repeatedly, like bringing up a new environment. And subcommands are a beautiful thing where when you run Atmos, you can actually you can introduce any of your own commands. So if you are relying, still you have a bunch of stuff maybe in Terraform. Maybe you have some stuff that you deploy with Ansible. Maybe you have some stuff that you deploy with a bunch of other tools or in-house tooling, and there's just no consistent way that you do that. Atmos subcommands are a great way to expose a consistent interface for your developers. So they run one command, every command is documented, it supports arguments, it supports flags, and it's a great way to standardize that interface to your various shell scripts and tooling. So that's one part about it. And then, of course, Atmos natively supports Terraform and Helm file, and extends it with a few things like generating backends, generating the var files, and so forth. Which is what's so cool about Atmos is that there's zero vendor lock-in when you use Atmos, because you can run a single command to generate all your variable files and never touch Atmos again. Few tools that wrap Terraform or call Terraform can make that claim. You can't do that with TerraGrunt, can't do that with Terramate, you can't do that with a lot of tools because they're actually modifying your Terraform projects to achieve some optimization. Questions for everyone. If you have been using Atmos, what are some of the things you'd like to see documented? And let's see if we have those documented. Feel free to add those to the Slack chat or bring it up here.
One question, Eric.
Mm-hmm.
When you create new commands with flags and such, does some form of shell completion become available somehow?
No, that's a great thing. It would be super easy for us to add, and I bet it's already supported by whatever I forget what we're using to parse all the arguments in Golang. But adding shell completion would be very useful. Cobra.
Oh, sorry.
I bet Cobra supports some way of producing those shell completion commands. So we should make a note of that.
That'd be awesome. Yeah.
Let's do this live on the call. Let's make sure we don't have anything for shell completion. Tab completion. Okay, we do. We should bring this back to life. Let me rename this to shell tab completion. All right, we'll make a note of that. Any other questions?
How would this fit in a posture you're trying to establish where you have a template set up for your Terraform stacks?
So that's a good question. So templating, first and foremost, is, well, how do I want to introduce this? So templating is a tried and true method, right? It's an established convention. There's tools for it. There's things like cookie cutter that will generate files from templates, and then templates suffer from a big problem. Once you've generated it, it's very difficult to manage the outcome of that. So templating is a strategy to easily and rapidly and consistently create new configurations, projects, and so forth. Are we in agreement before I proceed?
Love it. Yep.
So what if you didn't really need to do much templating at all? And what if instead you created a library or like a service catalog of your configurations, and then you don't really need any templating at all because you just import what you need and change what you don't. And what I mean by that is, if we look at one of our stack configurations, jumping back here into like orgs, plat, staging, US West 2. All right, so I guess we could do some templating of configure. Well, okay, so there's Terraform projects and like your HCL code, and do you need to do templating there? I'm going to say you don't need to do it, and it's most of the time an anti-pattern. There's a few exceptions to it, but most of the time it's an anti-pattern. And I can say that because we've deployed enormous environments and not needed to do it. The one thing that we generate today are Terraform state backends, because Terraform itself doesn't support parameterization of those backends. But for everything else, we have managed to find ways to not do it. We're talking multi-region, multi-account, multi-organization, all of that, all happening at the same time without any Terraform code generation, except for state backends. So we've been able to do that because we write smaller Terraform root modules that are very composable, that you can have, that you can combine to build up an architecture. So in this case, we'll have a root module for a VPC. We'll have a root module for ACM, a root module for WAF, a root module for EKS clusters, a root module for Postgres. And when we construct an environment, we then pull in those root modules, but each one is deployed separately with its own Terraform state. That means that we can have as many EKS clusters, as many RDS clusters, as many VPCs, as many as anything that we want without touching a single line of Terraform code. And we also get the benefit of reduced blast radius, that we can target any one of those, components without affecting the other components at that time when we run it. So the question about templating, what about templating? In my mind, where templating comes in with Atmos is in two areas. If you are like Cloud Posse and you have a blueprint for how to do infrastructure and you want to distribute that to lots of companies, there are some things that we would still want a template. For example, in what we have here and under orgs, this thing called CP Live, yeah, well, somebody else isn't going to have CP Live. We own that. So that should need to be templated. And there's a few other little constants throughout that would maybe want to be templated. The other area is, what if you're using some third-party service like ServiceNow or something that manages service catalogs, or you want to automate the creation of new services but for a team? Then what you want to do maybe is have something that would generate configurations like this staging configuration on demand based on what a user selects. And how easy is that? Like, you could imagine a UI where you're checking off, I want a VPC, I want an EKS cluster, I want SES, and then present the user the option to override some settings at the end. So this is where I could see that, but it doesn't need to be templating, because this is a data structure. This is YAML. So you can just represent YAML in whatever language you're using as objects and then produce this output, so templating isn't needed. So that was probably more than you were asking, but I guess it's all what you're trying to solve in terms of templating.
Yeah, well, the only hang up that I have there is that import in Terraform is not import as it is in other languages, right? It's HCL. They want to grab pre-existing objects with import there. And there's no import that we would understand to grab code and treat it as a root level module, right? Like you've got to do the variable pass back and the outcome output, rehydration into the upper level. It's a lot of legwork.
So I'm not following entirely. So so we are not talking about HCL at all at this point, really. We're just talking about how do you create the Terraform variable files.
Yeah, no, you've got an entire different thing here with CP Live.
Yeah. So so to be honest, Atmos is a wrapper, just like TerraGrunt is a wrapper, Terramate, and all these other alternatives. In fact, under our Atmos tools, this might help other people who are trying to grasp what the heck is this tool, because it is a little bit foreign. If you go to reference here, alternatives, we've kind of inventoried the landscape of all these tools and called out where we've borrowed some of the concepts of them. So Atmos is a broad tool that doesn't fit into any one of these categories because it has elements of Make. It doesn't really borrow from Mage because Mage is like a Golang native way of creating runnable, like a task runner. But it does borrow on concepts of like task and task file and how that works. We wrote the first version of Atmos in the language of Variant, actually. We ported it to Golang afterwards. The way we talked about subcommands, we implemented that based on what we found with Choria and App Builder. It was really cool. And then you have the tried and true methods out there like TerraGrunt, which has been out there forever and has a lot of great concepts, like the way you can download root modules. We implemented it a different way with what we call vendoring. TerraGrunt, will help you manage, Terraform initialization and so forth, which we do as well. Terramate is a new kit on the block by a company called Mineros. It does some cool things like change detection in Git. This is coming to Atmos soon, but it's not there yet. Terramate is doing code generation and simplifies that. We could very easily do that, but as a principle, we are trying to not do that because we think that it leads to difficult code to maintain, test, and validate if the code itself is dynamic. TerraSpace, in Rails, TerraPlate, which is just for templating, Astro by Uber, and so forth. So these are all the tools that we kind of replace by picking Atmos.
Yeah, I like your take on that. Like, I don't want generated code per se. I want a world where we can say, here's some code as, for example, common variables and common tagging for an organization. Say you've got cost center tagging requirement. You want everything to be aligned on what people are doing with their tags. Yeah. Just being able to say anyone who launches this product to start with this, or be able to do an import. So you've got all of that kit just out of the box without having to copy and paste a bunch of baloney.
Exactly. You got that.
Yeah. And that is what Atmos brings you, like by using it that way. So it's doing configuration inheritance, right? So you can define all those things that you talked about at the top levels, and anyone who instantiates one of your components in a particular environment, in an account, and whatever, will automatically pick up all of those things that you defined at a higher level without having to specify them over and over again. So it's pretty easy. So, and just to be clear, what this is doing, like in a nutshell, is it's taking all this YAML, it's deep merging all the things that are imported that are listed as imports there, and then it's creating a single Terraform DARS file that contains all the merged variables, and then it's passing it along to your module. So that's really all. That's the magic, quote unquote. I don't want to say that's all it's doing because that in and of itself is hard, but that's the TLDR of how it actually works. It takes all of those things, and then we have a convention that we call the context. So it's context.tf that contains things like tagging and naming and all of those things that we use in every module, so that those variables that we just talked about are available in every root module. So so there you go. So things like tags and name and how your environment, your namespace, your tenant, attributes, etc. And then you can generate like names based on all of that thing for your resources. So we basically copy and paste this one file into every new module we create, not instance of the module, but when you're creating a new Terraform like root module, you would copy context.tf so that you get consistent set of of variables that you can use over and over again. And then Atmos does the hard work of merging all the config together to give you like a Terraform var file that you can then pass to that module that has all the values already predefined. Even if the user of that module is only defining like one or two things, you'll still get all your organizational tags, et cetera, that you defined at a higher level. So hopefully that makes it a little bit.
Sounds like exactly the solution I need to solve some of my problems. Is there a YouTube video that goes through some of what you were talking about?
There's
What's that marketing material?
there is this live demo we did on Office Hours back in October. You can see a run through using it in action. And then for context TF, you'll find other videos like on our YouTube channel for those. So if you go to youtube.com/Cloud Posse, what you'll see under Cloud Posse Explains, we have a bunch of
Pay for the subscription. Get rid of those ads.
Exactly. Learn on demand, everybody. Udemy brought to you, not by us. All right. On the side here, you can see some of these explains videos that we have, and those are out.
Very cool.
All right. Any other questions on Atmos documentation?
I was curious if there's any documentation on using something other than YAML or JSON, such as DAL.
No, we haven't adopted anything else yet. I wouldn't rule it out like in the future per se, but we are pretty opinionated on using YAML now. Where we have diverged from that, or like where there's one exception to that I can highlight, would be if we go back to the docs and we go to core concepts of validation. So we support JSON schema validation, OPA policy validation, and the JSON schemas are obviously defined in JSON, not YAML. And then there's one thing we didn't list here, but we also support QLang for validation. So you can use QLang to express what you want to do there. But we're not talking about the stack configs themselves. The stack configs will continue to be in YAML for right now, at least.
Okay.
Although Atmos is extensible. You can write your own workflows in Atmos. So you could, in theory, write it in whatever you want as one of the steps. You could convert it to YAML and then pass it to the Atmos Terraform commands, which would then do all the same magic that you expect them to do in there. So while we don't support it out of the box, we support extending your own workflows that would make that possible if that were something you really wanted to pursue.
Sure. And again, I'm speaking only openly that, I mean, I imagine that's really what I would do. I only mention it because it is nice to have a quicker workflow for things like type safety and configuration, for instance.
And what was the language? What was the format you said? DAL? I'm not familiar.
DHALL.
Mhm.
It's a type safe configuration language. DHALL. Sorry.
Yep.
Yeah, DAL configuration, which
Although to be frank, you can actually do the majority of what you would do in DAL with JSON schema plus our YAML. You know, we need to do a little bit more work, and we are doing that work to define published JSON schemas for our YAML formats. Even though I'm saying JSON schema and YAML, I don't know if you realize that you can validate JSON, you can validate YAML with JSON schema. It's just like the way that it works, because under the hood they like translate to the same thing. So what we would then do is we would have a step that automatically will validate the type, the types correctly for your inputs of of YAML. But in the meantime, you could actually just use a DAL to YAML converter in a workflow step, and you
Oh
would just
yeah,
like pass it
absolutely.
there. Yeah, and then it would work.
Absolutely. I only asked only because again it's one of those things where one less step of customization is nice. But yeah, I was purely curious about that. I know that in the past I've goofed off with folks who will also have their own little Go package that provides their own Terraform provider for their own custom sort of kit that they throw on servers. But that's another thing that I've been curious about. But that would be another example of something where I would just have a Go compile step to just make sure that the plugin is available before Terraform runs. But yeah.
Yeah, that's actually what we do for some of the things that we need to do with Atmos. So we actually have a Terraform provider that can read the Atmos stack configs as well and work with them in Terraform. So, yep.
Yeah, that's it gives something to noodle on at least. One concern, or somebody can clarify for me. I mean, it doesn't look like the Golang implementation receives much updates. Maybe it doesn't need it, to be clear. But when I see things haven't been on the majority updated for years, it gives a pause, and no release for 1 year.
Sure. I think that DAL themselves will say they try to avoid doing a lot of changes. I know that the joke tongue in cheek is proudly not Turing complete ever. Which is kind of a part of the joke of when you start digging into the functions and the design of the language. It's definitely meant to always turn into one singular file and never have any state. But I think that their current push right now with DAL is mostly in integrating it with things like Kubernetes. So they have a variation where you can have kubectl send DAL files instead of YAML, and other sorts of fun things that they're working on. I'm not sure what the team is currently focused on, though, to be clear. So they're not very big. So I just know that if I had a problem, I would just go to their repo and probably make a fix and give them a pull request, and then potentially they'll merge it. Like you saw, there haven't been updates in a year, but
Yeah.
maybe that's because there's not been any breaking changes. But it's purely an example of just type safety and configuration, which I think has bitten me in the past a lot. And while I love OPA, I love JSON schema, I've used it before. If you are using a lot of configuration, they can be, I mean, I guess not OPA per se, but OPA has tooling that might be something you're allergic to. Whereas I feel like JSON schema, I've had my moments of it taking a while to update and to add the type safety that I want. Whether that's a good case for talking about it or not, I don't know. I just always am curious if Atmos is extensible for its configuration languages. That's why I was asking. That's all.
Yeah, no, I think it's an interesting idea. I think given the slant that we support a lot of Terraform, maybe it would be something like an HCL first. I personally been a little bit concerned about picking up something a little bit more esoteric just from an adoption standpoint. We picked YAML because everybody understands YAML in the end, and that's kind of like,
oh yeah. And again, all that I'm asking is if there was any support for, say, in Atmos to say, hey, here's this utility, use this to run these files and get the JSON back out. Actually, really was all that I was thinking. I wasn't thinking about anybody actually having to support DAL support in Atmos. That'd be kind of silly.
So that's exactly what I was suggesting. You can use the workflow, the workflow capability. You could define your own workflow so that it will then run your CLI, convert DAL to JSON, to YAML, and then pass that YAML basically into, that YAML would then be what Atmos operates on as the configuration that it does all its deep merging and, you know, yada yada with at that point. You know, then it will merge all that, can create a Terraform var file, and then pass that var file over to over to Terraform for Terraform to do its work with it.
Yeah.
So just to be clear, Atmos is a workflow tool at the end of the day. Like so we just have an opinionated workflow that we've defined for running Terraform from our stack configs, but you can define any kind of arbitrary workflow you want in Atmos. You give it, and you can give it your own subcommand name. You just define what the steps are that run, and at that point you then have a full-blown work. Like you can run Atmos, Atmos Jeremy apply at that point, and it would go and run your command under the hood to get YAML, and then it would run the rest of our command from there. So it's pretty extensible from that perspective.
Okay, cool. And yeah, no worries. That answers my question.
All right, cool. Well, the last thing on my announcements, and then we'll get to Q&A, is Cloud Posse is actively hiring. If you go to cloudposse.com careers, you'll see a little bit more about the opportunity and what makes it unique. If you've been interested in kind of shifting your career towards open source and doing more with that, working with Cloud Posse is a unique opportunity to be able to do that. Also, you'll be backed by a community who loves what you do. So it's an interesting opportunity also for people who get bored easily at their job, because at Cloud Posse, you're constantly context switching, every few months at least, between different customers. We do short engagements. It's, there's no staff augmentation, no PagerDuty on-call services. So it could be a breath of fresh air. So if you're interested, reach out to us at Cloud Posse, go to the career site and apply. Last, so talking points, there was nothing posted in the office hours channel earlier. So let's see if there's been any updates there. See here. Cloud Posse office hours. And I don't see any questions posted. Anybody have any questions that we can answer today? Anything goes, pretty much.
I've got a question.
Go for it, Jan.
Might be, considering Cloud Posse's past, might be slightly controversial. One of the things these days, I'm at a company where the vast majority of our fleet runs in Google, GCP.
Okay.
When can we expect Cloud Posse for Google?
It's probably not too far off, but we're going to take a different approach when it comes to Google and probably other providers as well. And it is a practical one. So, what I always bring up is that, supporting AWS as we do, we have over 100 modules for Terraform, AWS, something, right? 199 shows up here. We're a small company, relatively speaking, and supporting Google Cloud, I would hate to see another 200 modules show up here. Obviously, Google supports a lot less than Amazon does. Amazon is the 800-pound gorilla. But what we can do is leverage Google's own official modules. So unlike Terraform AWS modules, Terraform Google modules is actually maintained by Google, the company. Yep. So we would probably start here, but we would be obviously at the mercy of whatever they support. So they have some 64 modules, it looks like.
If you do at some point start doing that, even before you start actually making it public, please do shout. There's a lot of the lessons I learned from the Cloud Posse kind of pattern and the geodesic pattern.
Yeah.
That where we are currently, I mean, we currently run across sort of Azure, AWS China, which is not like normal AWS, and GCP, essentially with the same code base, the vast majority of the pattern being pretty heavily inspired from geodesic. So I'd be very keen to sort of talk shop around your thinking on and the approach and that kind of stuff. It's one of those.
Now, so for everyone else, John was a really early follower of what we do here from like 3-4 years ago, almost generation before where we are today with everything. When at that time, almost everything we did was based around Cloud Posse geodesic. We used a lot of other conventions at that time. We still rely every single day on geodesic. Geodesic is wonderful. It's basically a toolbox image for everything. But the one thing I'm not sure if you're familiar with Atmos is also how we leverage our AWS components.
Not yet.
And so AWS components, so what we would do is we create Terraform Google components, and the Google components would have here, and those are basically opinionated implementations of what you would find here. So you would take, like, for example, you want to deploy a GKE cluster. You would use this Terraform module, and let's go to examples here. So here they have a few different examples of how you might invoke this. Now, for your company, you're probably going to have an opinionated way on how you implement it. Let's take an easy example here of just provisioning like a node pool or something.
Mm-hmm.
So this is provisioning module with GKE and so forth. Let's compare that to how we would do it for EKS. So we jump over here to our EKS cluster root module. This is a Terraform root module. And under the hood here, it's going to be calling Cloud Posse's cluster module. So you can see the parallelism here, that if you were to create components for GKE, it would be very similar. You would just, invoke something like this and update the variables accordingly. And probably version them separately. Instead of having one repo for multiple clouds, I'd probably break them out by having.
Yeah. I mean, that's definitely, so we do one sort of repo for high level declarations of configuration that are truths for at like an organizational level. And that's actually almost at like an organizational entity level, not sort of company level. And then we break down, so each cloud is essentially completely sort of separated, and then down to the point where we've got actually individual layers in different sort of organizations and different sort of repos. And then we must get together and catch up at some point around this.
Definitely. Yeah. So this goes for you. This goes for anyone on the call. If you ever want to book a time with me, it's very easy. Go to calendly.com/cloudposse and book a time. Would love to talk to you or anyone else here. Love to talk shop with the community.
Eric, there's a question that was asked in the meeting chat, in the Zoom chat, about considering that Atmos is relatively new and trying to gain maturity. What are the thoughts about how safe is it to use this, given that Cloud Posse is a small organization in the enterprise, and Cloud Posse is could go away at some point. How confident are you that you could use this over the 3 to 5 year lifespan, something like that?
Yeah, this is the picture comes to mind of what is this meme with entire internet supported by one open source project.
Oh yeah,
is a good one if I got it.
It's dependency XKCD, right? Isn't that
this one here? This is basically what we have today. Cloud Posse is one of these little things. I mean, the same is true of like the Cloud Posse ecosystem. We see some of our Terraform modules are provisioned tens of thousands of times a day. You can imagine the same thing being true with other Terraform modules like Terraform AWS modules. Now, a fun fact about Terraform AWS modules is this is not a large organization, and it's not backed by Amazon either, and it's not backed by any company. It's a bunch of individuals. So, I mean, there's something to be said by that. I would say one of the things that makes this a more robust project is that it is backed by a company whose financial interests are aligned with it. If you look at a lot of the other tools that are like Atmos, TerraGrunt, used by half of terraformers out there, it is also backed by a relatively small company. So this is part of the risk landscape when you're using open source. Open source is free, but it's not really free to implement and use. There's going to be trade-offs there. So,
yeah, the other thing to point out with that is, should something happen to Cloud Posse and Atmos went away and wasn't supported anymore, there's a command that you basically can generate plain vanilla TFVars files from all of your stack config, and you can eject, quote unquote, from Atmos. I wanted to call it Atmos eject, but I was overruled. But you could basically just get out of there and move on to whatever your next replacement solution is if you needed to do that. Hopefully that won't happen, and hopefully this is a long-lived project, but there should be some security in there that there really isn't lock-in. You can always get back to plain vanilla Terraform at any time you want. You just have to then manually run the commands instead of running them as part of an Atmos wrapper.
exactly. That's the thing. That's why there's so little risk in this project to use it. You can always move out. And also what's interesting about it, because we have this command, it means that you can integrate Atmos more easily with conventional CICD pipelines. You can generate all the var files, commit them, and use Terraform Cloud. Generate all the var files, commit them, use the Atlantis project, or use GitHub Actions. So it's not an afterthought. It is becoming a core concept of how we think about Atmos, is making it so that there isn't vendor lock-in. So hopefully that dispels some of the concerns. If anyone else has some concerns, we'd love to hear them.
I mean, whatever the concern, if someone's got a shovel, they might as well use it till it breaks.
Yeah. That's a little bit like this. I would say that's the larger concern. It's an existential one. Are we going to be talking about Terraform in 5 years from now? Right? Will Pulumi have won the day, or what is it going to be? Right?
Well, that's a joke, because isn't Pulumi kind of dependent on Terraform right now?
Yeah. Go ahead.
Oh, Matt.
No, I was gonna say that they've their initial version of their AWS provider definitely was doing that, but they've the newer iterations now have started to natively use the Cloud Control API, and they've gotten
So it's no longer the gRPC
dependency
madness that I remember seeing in the past.
It depends which. If you use the Terraform, if you use the Pulumi V1 provider still, then it's still there. But if you upgrade to their V2 provider, which has been out for, 3/4 of a year, or maybe a little bit more than that at this point, like stably, that is definitely moving away from that. And in many of their other providers that they have, they don't rely on Terraform interop in order to do the work that they do. So I think that was their quick and dirty get to market strategy, but they've been iterating and trying to break that dependency for some time now. So
Oh, that's cool. It's been a while since I've used Pulumi. It's been like maybe a couple of years, really.
Yeah, it's improved significantly.
That's cool.
I don't think we have too much to worry about. AI is getting to critical mass. Very soon will be, okay, Copilot, do build Google. It's gonna happen.
Yeah.
I just think of the person who asked the AI to draw salmon in a river, and it just showed sashimi salmon fillets. like swimming upstream. And I just think to myself, is that what's going to happen? We're going to say, hey, I need an ingress controller, and it decides to, just deploy Nginx, with a hello world instead of actually connecting your service or something else like that.
Well, I mean, you're going to have to be explicit, right? Deploying, you're going to have to be explicit to the point where you might as well just go and write the damn thing in code.
Yeah.
Oh yeah, there's the meme right there.
Beautiful.
So I do think that we have a ways to go for AI to get its context straight. For what
This
it's
for real,
worth.
or this was just a meme or it's a joke?
No, it's real. It's real.
I'm naive.
Oh no, if you ask, I
Yeah.
guarantee you right now, if you ask AI to draw anything that's adjacent to food, it's very likely that you're going to find something else. Like
Oh,
there's probably somewhere on the internet somebody tried to say, draw me fried chicken, and it's literally a deep fried looking like chicken trying to, walk around on the ground. Like that's AI right now. But
Well, it's informed by mass consensus, and ingesting Instagram says fried chicken. That's KFC.
yeah.
It's one of those curiosities of is the context that you give the AI mature enough? And that's the other part of it, right? Is I don't know if there will ever be a critical mass of information that you would need to feed an AI for it to necessarily govern infrastructure well, except in scenarios where you're absolutely a super massive organization. And I bet you that that's one of the fun things to discuss in maybe another year and a half. But
Yeah, building that context slash, intention matrix, like that's a challenge.
Yeah.
Oh,
So
yeah.
I have just really quick thing. I know we're just about out of time, but for anyone who watched, Silicon Valley on HBO, and they built the AI, the hot dog or no hot dog, detection thing. I laughed the other day that I saw that Bumble, the dating site, has actually built that now
Awesome.
to detect whether or not people are sending unsolicited nude images to people on the platform, and they can now stop it and flag people's accounts. And they actually open sourced a bunch of the technology they use to do it. So it's pretty. I kind of laughed at where AI is going these days now. Where like a few years ago when they talked about that, you thought it was just like this stupid joke, but someone actually built that AI now.
Yeah.
It's a hot dog.
Very fun.
Maybe
All
we
right,
just need to
everyone.
have the right package for all of it, just have the salmon library for being able to identify salmon.
Yeah, and install it with Atmos.
Absolutely.
So thanks everyone for your time today. We are out of time. We're at the top of the hour. I want to be mindful of everyone's time. Please go to YouTube and subscribe if you want to support what we do here at Cloud Posse. Appreciate it a great deal. Connect with me on LinkedIn. Go to linkedin.com/in/Osterman. If you're interested at working at Cloud Posse, head over to cloudposse.com/careers, or sign up for our newsletter maybe. If you like all the good links that we share every week, those will be syndicated out to you. Go to newsletter.cloudposse.com. Thanks everyone. Have a great rest of your week. Bye-bye.